Hey everyone, welcome back. Today's topic is database indexes, the secret behind lighting false data lookups. If you have ever wondered how databases handle quick search on massive tables, this is a table for you. Let's dive into it. As always, we answer the what question. So, what is database indexing? A database index is essentially a super efficient lookup table that lets your database find data way more faster. It holds two things: the index column values, like an order list; number two, pointers, like to a corresponding rows in a main table. This means instead of scanning every row for a match, the database can jump straight forward to where the data lives using that index. Okay, let's try to understand why we should use them. Without an index, the database might have to scan through every single row in a huge table. Imagine flipping through a book page by page. But with an index, it's like checking a table of contents of or an alphabetized phone book. The database can zero in one in on it can zero in on exactly where the desired data is stored, making queries way more faster. Okay, let's try to understand how does it work. Okay, we have this one too. So we have here indexes and we have here the data. So we have the indexing creation, like you define which columns you want to index. For example, we have like property 1, property 2, things like that. Another database will sort or organizes these columns values in a data structure, often a B tree, okay? We have after that the lookup, like when a query filters by the indexed column, the database consults the index first. It finds the matching entry and follows a pointer to retrieve the raw data from the main table. Number three, we have the results. Like the query executes much faster than if it had to scan every row. This is why indexes are so critical for large or frequently queried tables. What are the trade-offs of that? Like, what are the pros and cons of indexing? First, let's talk about the pros. The pros, we have faster reads, like speeds up select queries significantly. Number two, efficient lookups, zero in on specific row quickly. Okay, or rows quickly. But what are the cons? Slower writes, like insert, update, and delete operations, it can be quite slower because the index must be maintained. Number two, storage overhead, like indexes require additional disk space. Number three will be the over indexing, like having too many indexes can actually hurt performance and complicate maintenance. Okay, when to index? We have three cases. First, if you frequently queries, like if you regularly filter, sort, or join on a column, an index is highly beneficial. Number two, primary keys. Like most databases automatically index primary key columns for faster lookups. Number three, unique columns. Like if a column must be unique, like email address, indexing helps enforce uniqueness and speed up the searches. Okay. I guess that's it. We can make like we can also talk about best practices as oh yeah. Let's talk about best practice because we used to do this all the time. Practice. Okay. The first one, identify columns frequently used in queries like where joins, ordered by, things like that. Number two, keep track of how often you query these columns. Number three, monitor performance to ensure your writes aren't too impacted by index maintenance. Number 4, regularly review and prune unnecessary indexes. It's easy to create them but harder to remove them if they are no longer needed. Okay, let's wrap up. So that's the scoop on database indexes. They are your go-to tool for speeding up data retrieval in large tables. By carefully selecting which columns to index, you will optimize your queries without creating too much overhead. Thanks for watching this video. If you found this video useful, like and subscribe for more database tips and system design insights. Feel free to ask any questions about indexing or share your indexing experience in the comment section below. Until next time, happy querying, guys.